I think it took a lot of space. Yeah. Hope I think everyone is able to see things clearly. No. Okay, this is what we had a discussion. Okay, this motion will represent practically how do it occurs. First, we can't move it. First, what is a motion? This is O. This is A. This is B. C. There's a rough thing. So here the speed of object will keep on increase. So this is what we were showing it like this. And the acceleration was like this here. You call A dash or what will be that. Or AOA, acceleration. Then afterward, the object will be still moving towards right only. Then the speed of object, what happened? It was undergoing retardation. A, B. Then finally it has come to rest, then change direction of motion. I'll draw a better diagram. I have to represent everything. No? Yeah. So this is the O, A, B, B, C, and this is D. So this is the V1, V2, the acceleration AOE. There's a physical motion. Physically it happens. This is a graph. This is what physically happens. Here the speed of particle V3, V4, it will undergo retardation, and here instantaneous rest. At B for a while, it will be at rest. It started from rest. And finally come to rest here. Slope here will be 0. Here also slope is 0. That's what I assumed it. Then here V5, V6, V7, V8. It will undergo retardation. It will undergo acceleration. What all I wanted to describe everything I'm putting. First, the body will start from rest. It will accelerate. Speed of object increases. Becomes maximum here. Then here it starts undergoing retardation. Undergoes retardation. You see acceleration opposite to velocity retardation. Speed of the particle decreases. Comes to rest. Here slope is 0. Instantaneous rest for a while. Again it starts accelerating, but acceleration is towards left here now. The speed of particle is increasing. So don't call this a retardation. This is the acceleration. This part is retardation. CD is retardation. The speed of particle decreases. So what do you mean by acceleration here? Speed of particle increases, acceleration. Speed of particle decreases, retardation. Acceleration can be positive or negative. Retardation can be positive or negative. Are you seeing this part? So I am explaining something very beautiful part of this kinematics here. Now the definition. This is the acceleration. This part is what? Retardation. This part is again acceleration. And this part is what? Retardation. If I didn't describe this, there is no meaning of only ST graph. ST graph, any teacher describe ST graph without this, it's of no use. Acceleration can be positive. Yes, you see this. Look at this acceleration, AOE towards right. Acceleration ABC it is also positive, but how it will be directed negative. So acceleration positive negative doesn't mean that it's a retardation, but in numericals, we do treat like that. I think you have to be very careful about the situation given. Retardation, look at this retardation, is directed along positive x-axis. So therefore, how do we say body side to be accelerating? If speed of body increases, the body side to be accelerating. If speed of body decreases, the body side to be decelerated or retarded, and anything we can use. Okay, this is something very, very important data. Speed of body increases, acceleration, speed of body decreases, retardation, that's all. Acceleration can be directed along positive x-axis or along negative x-axis. Retardation can be directed along negative x-axis or positive x-axis. That's what I'm trying to, I'm explaining using this particular graph. In FT graph, if you draw a tangent, it will give the slope of tangent on at various points. What it will give? It will give us the instantaneous velocity. So speed increases, acceleration, speed decreases, retardation. Okay, I agree this. So there's one background is what we needed. So what is the requirement like? If you know VT graph, if you know VT graph, you should know how to plot ST graph. If you know ST graph, you should know how to plot VT graph. There's a meaning of the curves. Okay, here I just described, here there's a physical motion, there's a path. So how the object, it will move like this. It will move. And it will retrace path that the graph will be very difficult to show. Therefore, we are just taking some curve here. So don't take again, it will take a turn, sir. What is the radius of this curve? Nothing. The body will go like this and will return back. This to show all the things, we are showing different path, but actually it will retrace path. It will go there, will return back. Fine. This is very essential. In books, they try to explain. Here I'm just giving a little bit a better explanation, you can see. So AOA, acceleration, positive x-axis. ABC is again acceleration, but again it is along negative x-axis. So be careful so that this data will trouble you. Let me move to the next one. Means like from FT graph, we can even tell a body is said to be accelerating or retarding. Am I right? From position versus time graph, can you say a body is accelerating or undergoing retardation? Yes, we can predict. Can you predict the velocity at any time by the slope? Can you calculate average velocity? Yes. Can you calculate distance covered, displacement? Yes. So so much of information available. From FT graph, even we can determine a body is accelerating or undergoing retardation. This is what I mean to say. This I didn't cover in the beginning because at that time we were not knowing acceleration idea. From FT graph, what all we can find out. Once again, I'm revising. From position versus time graph, we can predict instantaneous velocity, average velocity, distance covered, displacement, acceleration, or retardation. So this much of wide information is available from these graphs. Let me save it.